righty, here we go. Hey, what's a triangle? Shirley?
A shape with 3 sides.
A shape with 3 sides. Okay, so here's what we're gonna do. Since this is our first time writing definitions after we talked about our logic unit and you understand the importance of if-then statements versus reversible statements and all that other stuff, let me refresh your memory that in order for something to be a good definition, number one, it has to be an if-then form, and number two, it has to be reversible, meaning if it's done correctly, then the converse of that would also be true. Okay, so as you write definitions, what I'm going to do is try to find counterexamples of your definition to see if it actually works. So you said what?
A shape with 3 sides.
A shape with 3 sides, okay. Let's see. Can I come up with something that, ooh, this is good. A shape with 3 sides. 1, 2, 3.
It's not a star.
Is that a triangle?
A 3-sided polygon.
A 3-side, well, what's a polygon? Have we defined a polygon? That legitimate question, I don't remember. Have we defined a polygon?
No, we didn't.
We didn't? Okay. So we can use your definition if we then go and define a polygon. What's a polygon?
Shape with all closed sides and no curves.
A shape with all closed what's a closed side?
Like all the lines are connected and they don't curve at all.
Is that a polygon?
No.
Well, those lines don't curve and they intersect.
Yeah, but it can't be like open like they are in the corners.
What do you mean open? It's closed right here.
They don't intersect. They don't intersect.
They don't intersect, okay?
They have to be like together.
They have to be together like they're dating or married or
Married.
They're
just
married.
friends?
Married.
Polygamy.
They're married,
Yeah.
okay? Good. Mary, what were you gonna say?
I have one for triangle. but-
Wait, we're going to triangle, so we're not gonna do polygon?
We are doing polygon.
Well, hold on, let's get the rest of you involved here. What do we wanna do? So Rex gave me a definition of a triangle as a 3-sided polygon, but we don't know what a polygon is, so we can try to pursue the definition of polygon, or we can take a different approach for defining a triangle. Preferences?
Polygon.
All right, polygon seems to be the consensus for those of you that are capable of speaking. Mary?
Okay. I was just gonna say, I'm trying to work out a shape whose angles, when added, equal 180 degrees.
We don't know that, unless you can prove that.
If you were to measure.
Then we'd have to measure every single triangle possible. That could take a while.
Right.
Yeah, I don't have that much time right now. Excuse me. Okay. Yes?
The angle measure, did we say this already? The angle measures out.
Well, I don't know, you were here also.
Yeah,
Did we
said-
say this already?
Yes.
We did just.
Go.
It's a shape with any amount of sides. They all.
Any amount of sides, all right?
All connect. They don't intersect. and
How can they connect and not intersect?
At the points. They connect at the points.
What points? Because these connect at a point,
The end of the line.
Endpoint.
the end of the line
The
also,
end point.
okay, now we're getting warmer. Say that again.
They connect at the end point.
What's they? I hate
The
pronouns.
lines.
The segments.
Yeah, segments.
Segments connect at the endpoints.
Yeah.
That's it? Any number of sides?
Yeah.
Which one are we defining? Triangle or polygon?
Triangle.
Triangle.
3 sides.
3 sides.
Well, you just said any number of sides.
Well, that's a polygon.
Which one are we, hold on, I'm so confused. Wait,
That's
let
what
me,
it says.
hold on. Okay, let's start over. Are we defining a polygon or a triangle?
Polygon.
We're defining a polygon. Okay, a polygon is
The shape with any amount of sides.
any amount.
They don't intersect.
Can 2 be my amount?
No.
Okay,
It's
so
more than 2.
more than 2.
Yeah.
Okay, alright. Any amount more than 2.
Yeah.
Okay.
They don't intersect.
What's they?
The line segments.
The line segments don't well, they do intersect though.
The line segments connect at the endpoint,
Okay.
and they have to be closed. The line segments have to connect so there's a closed shape.
So the shape is closed, not the line segments. Because line segments are one dimensional, so they are closed.
Yeah.
Okay, could you give me that again once more?
It's a shape with any amount of sides.
Wait,
more
let's
than
put the
two.
closed in the front. It's a closed shape,
It's a closed shape.
so it has a distinct inside and outside.
Yeah.
Good, because that's where I was going. You know, I was gonna do this, right? But that's not closed.
That's not
So,
closed.
okay, so it's a closed shape.
With any amount of sides that get them more than two.
Okay, any amount as long as it's more than two.
Yeah.
Uh-huh.
And the line segments connect at the endpoint and they create a closed shape. Is that good enough?
I don't know. Is that good enough?
So,
I'm trying to think of a picture that would not. It's a good one. I think that works. Okay, so let's put this in here. Polygon closed shape with no. With more than two. Come on, Reedy. You're better than this. More than two. You call them sides, yes, or segments? What do you want to call them? Sides?
Sides.
Sides. And sides meet, connect. What do you want to use there?
connect.
Connect at endpoints only. Well done. Okay, good. Now we have, yes?
You
Is not a good way to start a sentence.
You forgot to, add straight lines in definition, cause,
Sides.
oh.
Are we okay with that? Do we all know what sides means?
Yeah.
Okay, good. So sides are segments. Okay, sides of a polygon are assumed to be segments. All right. Good. Well done. Hey Rex, what's a triangle? Excuse me.
Okay.
Hey, don't choke to
Yeah.
death, please. It's a lot of paperwork for me.
A triangle is a polygon with 3 sides.
I like it. Good, good. Okay. However, little twist for you. Can you put that in if-then form, please? Because then we can check we can talk about the converse and make sure the converse is also true. And then we'll have a good definition.
Yeah. If something is a triangle, then it is a 3-sided polygon.
And the converse of that would be,
If something's a 3-sided polygon, then it is a triangle.
does that work?
Yeah.
Well done. So what makes that a good definition? Number one, we know all the terms that he used. We didn't know polygon, but Max took care of that for us. Number two, it's an if-then form, and number three, it's a reversible if-then statement, meaning that it's a good definition. I like it. And those are all different examples of triangles that we're going to talk about today. Okay, so now that we have the basic definition down, we're going to talk about all the different types of triangles, and we can classify triangles 2 ways. Are we good with this? Can I erase? Types of triangles by sides. Jack, what kind of triangles do you know about?
Obtuse and cute, right?
Excellent. But those are by angles, so we'll get to you later. Mary?
Scalene, isosceles, and equilateral.
Scalene, isosceles, and equilateral, which are what? Let's start with scalene.
Scalene is when all the sides are different, like, angles,
Wait, all the sides are different angles?
or they're all different lengths. And then,
All the sides are different lengths.
yeah,
Good.
and then
Isosceles?
isosceles is when.
Isosceles?
Isosceles
Good.
is when 2 of the sides are the same and then one is not.
Different, yeah.
Yeah, and then equilateral is when all 3 sides are the same length.
So is isosceles only 2 sides equal, or at least 2 sides equal?
Zach?
you say?
Exactly two sides.
Exactly two sides. Is that what you wanna go with? Because we can do either one. One of them separates isosceles and equilateral, meaning they're never the same thing. The other one includes isosceles as part of equilateral, so that isosceles triangles are not necessarily equilateral triangles, but all equilateral triangles would be isosceles, like golden retrievers and dogs. You with me?
Is it actually pronounced isosceles?
You'll see the spelling in a couple seconds. Isosceles.
So the C was silent.
Why would there be a C there if it was silent?
I don't know what
Why would there be E in front of there?
Isosceles.
Yeah.
I don't know.
That rolls
All
out.
right, how do you spell pterodactyl? PT something or another?
Yeah.
That's a good question. Okay, equilateral, all three sides congruent. Isosceles. Now I threw at least in there because it's a little more interesting if it could also be, if we could consider an equilateral. But if you want to erase the at least, we can do that, and we'll just proceed with the idea that an isosceles is separate from an equilateral. It's entirely up to the group. Erase?
Yeah.
How many want to erase? How many want to keep it? I mean, I don't really care. Do whatever you want. All right. Two congruent sides then. We'll go with that. And then the third, scaling. No congruent sides. Remember, we got tick marks here showing congruencies. No tick marks on the scaling because none of them are congruent. All right, by angles, Jack.
Right. Oh yeah. Obtuse.
Okay, so what's a right triangle?
So it's a triangle that has a right angle in it.
Just right angle? Only one?
Yeah.
Can it have two?
No.
Why?
Because if it has two, then it's not closed. It's not polygon.
Yeah, you'd have two parallel sides. Okay. So right has one and only one right angle. What was the other one you said?
Acute and acute.
What's acute?
It's like angle that is
I mean, we know what an acute angle is, but what's an acute triangle?
it has all the angles are under 90 degrees.
All the angles or one of the angles? I didn't hear what you said. All. Okay, all the angles are under 90 degrees. All right.
Wait, no, one.
Only one.
Okay.
And the other two are
Oh, no, all.
all. All three.
Yeah,
Not just two,
yeah.
all three.
Yeah.
Okay, all right, good. Good. That's what you want to go with. All right. What else?
Oh, obtuse angle.
Obtuse triangle. Remember, not just angles. We're talking triangles here.
Oh, yeah.
What's an obtuse triangle?
It has one angle above 90 degrees.
Only one?
Yeah,
You can't have two? Why not?
because then it wouldn't be a closed polygon.
Okay. Any others?
No.
Any others? You forget one?
Did you say right?
He did.
Yes. Okay.
I don't know if this counts, but does equal angular count?
What's an equal angular triangle?
Well, or is that? No, it's equal,
What were you gonna say?
That's what I thought too.
but that could encompass acute and
All the
So are you saying an equal angular triangle is an acute triangle?
no, not necessarily, it probably, it has to be.
Oh, wait, you just gave me like three answers
Yeah,
there.
sorry, it has to be.
Yes, no, and maybe all in one sentence. So an equal angular triangle is an acute triangle? Yes?
All the angles have to be the same.
Okay, so does that make it acute, obtuse, or right, or is it a separate entity on its own?
It's just separate.
It's separate.
Yeah.
It's separate, but it'd have to be acute because it couldn't be right or acute.
You just contradicted yourself. It's separate, but it's acute. So is it acute or is it separate?
Or it's separate.
It, okay. You said both again. Which one? Camille? I'm sorry, Camille? He's Camille. Yeah.
I don't
You
know,
come
I
to
think it
class
has
on
to be,
time.
like, both.
I came today.
You did, twice in a row.
Twice.
2 days in a row. I'm so proud of you. Yeah.
Yeah.
If you make 10 days in a row, we'll have a party.
Okay.
Okay.
That's right, 'cause you
Go ahead.
Don't take anything.
I feel like it's like both.
I'll wrap it up.
Like,
It's
wait,
both
how-
equal angular and
Yeah.
acute.
Yes.
Well, there's acute. Well done, Jack. That's one. There's two. Equal angular. All three of these angles are congruent. What can you tell me about those three angles? David,
They have to be 60 degrees
why?
because, well, because they all they add up to 180.
Do we know that?
Well,
Excuse me.
yeah, but
Yeah, well, we haven't really proved it
Yeah.
yet. Okay, so can we pretend to know it?
yeah,
All right. And so they would each be how big?
60 degrees.
Okay, stop a second. Mary, if each of the angles in that purple triangle are 60 degrees, is that equal angular triangle also acute, or is it separate? It's acute. So equal angular triangles are also acute triangles, but not all acute triangles are equal angular. Question?
Yeah.
I started with again.
Sorry.
It's a hard habit to break.
So if it's equal angular, that obviously means it has to be equilateral too, right?
I don't know, is that obvious?
Pretty much. Because
Is that obvious?
Yes.
Because with like when you had the isosceles one, the two had the same length. I noticed that if you have the third one there, the angles between the third one and the two are the same.
You know what I'm gonna say, right? Prove it.
All right.
You can do it now or you wanna think about it?
No.
Well, I don't really know how to prove it exactly, but I can just say that
Which isn't really fair, cause I
It's
cut you
math.
some slack and didn't make you prove it
it's
through the angles.
mathematical logic. You can just put together inside your head. You can sort of image them snapping together, and if they snap together at the right angles, they have to be the right length.
How do I grade that?
Keep going. It's my
Alright,
advice.
what was Max's thing about not about having to like shave off the extra protruding lines because they violate the rules?
What did you shave off?
You shaved this one?
The definition, like
Looking good, yeah.
you know what I mean. Just,
I don't know what he shaved off.
you know how you didn't stop the lines after they intersected?
The segment?
Yeah.
Yeah.
Um,
Cause they intersected, cause he didn't have them intersecting at the endpoints, he had them intersecting, well, I had them intersecting anyway.
if they intersect at a 60-degree angle, then that means that you have to shave them off there, and then if you do that 2 times more, it's gonna end up in a length, and that length is gonna all be the same.
How do we know
Why
that?
are we shaving? You know what I mean? Cutting off those extra lines, getting rid of them. Segments at the end.
That's not a proof though. Right triangle, 1. Good job, Jack.
Good job, guys.
What was the third one? The fourth one, sorry. Well, you gave us 3. What was the third one? I forget. Which one haven't we done? Obtuse. There we go. There we go. Good. 1 obtuse angle, 1 right angle. Notice I got the little box in the corner, the yellow box there signifying it's a right angle. Okay, you're told it's a right angle. You've got a box in the corner, you're told it's 90 degrees, you're told it's perpendicular. 4 ways to tell. Without that, one of those 4 things, you can't assume anything. It looks like a right angle. No, that's not going to work. What happens when we put those things together? Which we already started doing. So for instance, Charles is putting an equilateral triangle with an equal angular triangle. Can you have, for instance, Kev, can you have an obtuse scalene triangle?
No.
Why not?
Oh wait, yeah, you can.
Which one, yes or no?
Yes.
You can?
Yeah.
Do you all agree?
Yeah.
Draw one. Okay, so a number of combinations work. However, a couple of them don't work. Which combinations don't work?
Alright, obtuse triangles.
That's true, but I wasn't very clear. Pairing an angle classification with a side classification. Which of those combinations don't work? Sterling.
Equilateral, right?
Equilateral right triangle. Why?
Because an equilateral triangle, all of the angles are the same. And
Wait, do we know that?
No.
This is a right, acute, and scale.
Go ahead.
I think cause if you use like the Pythagorean theorem for the right triangle, if you have like all of them be one, it's like 1 squared plus 1 squared plus 1 squared.
1 squared plus 1 squared doesn't equal 1 squared.
Wait, shoot, never mind. No.
It's okay.
But that actually shows you why it's not a right triangle.
Yeah.
Okay, so that, Dana just helped you prove that, Sterling.
Thank you.
So she took an equilateral right triangle. No, you took an equilateral triangle and tried to apply Pythagorean theorem to it, and it didn't work, because 1 squared plus 1 squared isn't equal to 1 squared. Alright, there's one combination that doesn't work. What else? Need at least one more. Max?
A scalene right triangle.
A scalene right triangle.
No.
No, why not? What's your counterexample? Who said no? Nobody. Okay, good. I'm hearing voices. That happens all the time.
Sterling. No, I heard.
What do you got?
You have like a 3, 4, 5 triangle that is.
You're right.
Yeah, that, yeah.
Yeah, 3, 4, 5, 3 squared plus 4 squared equals 5 squared. So it does work. So you can have a scalene right triangle. What?
I knew it. You're the one who said no. Oh, never mind.
Alright, certain combinations work, certain combinations don't. For the most part, you can pretty much take one of the sides classifications and pair it with a angle classification. Like for instance, can you have an isosceles right triangle? Yes?
Yes.
We all agree, yes? Alright, good, we'll go with it. Question?
Yeah, since, didn't we change the definition for, isosceles to at least 2?
No, I thought we left it at exactly 2, right? Well, I forgot what we decide. Exactly 2. Alright, so let's talk about that isosceles. There's the stereotypical isosceles triangle. Two sides congruent. What are the congruent sides called? Anybody know? We'll call them legs. And the non-congruent side? That's a good guess. We're going to go the other way and call it the base. An isosceles triangle doesn't have to be sitting on its base. It could be tilted over on its side. Okay, so it's not the horizontal bottom of the triangle that makes it the base. It's the fact that it's the one side that's not congruent to the other two. We got a bunch of angles here. This angle up here is commonly called the vertex angle, even though they're all angles that are vertices. For an isosceles triangle, the vertex is usually that corner up at the top there. We've used the word vertex before, right?
Yeah.
Okay, good. Come on. There we go. Okay, this is the vertex, and then these are also vertices, but these are usually called base angles. Okay. The angles attached to the base. You could call this a leg angle if you want, but that's a little strange. And we know the plural of vertex is vertices. We talked about that also, right? Okay, good. All right, right triangle. We've done this already too. What are these guys called? Legs, this one? Hypotenuse, good. What can you tell me about these two angles? This one, here, I'll put a mark on the board. This one, and that one. Nancy.
Makes up 90 degrees.
Also known as?
Complementary.
Beautiful. Okay. Those angles are complementary. Why?
Because the triangle is 90 degrees.
Right, so we're gonna cheat and use what David told us earlier that we already kind of know. All right, keep going. Adds up to 180.
And since one angle is 90, the other two have to make up 90.
Good. What else can you tell me about those two angles? Anybody? Maybe not necessarily in this triangle, but let's suppose we have two angles. Angle X and angle Y, and they are complementary. What do you know about X and Y?
They're less than 90.
Also known as?
Complementary.
Got that already, but what is it called when they're less than 90? Good, they're acute angles. So we know that these two angles have to be acute and they have to be complementary. They add up to 90. Hypotenuse, we got the legs, we knew that already. We know that a squared plus b squared equals c squared. We've done some work with triangles already. Okay. Find the perimeter of that triangle. What's perimeter again? I forgot.
The length of all the sides.
Yep. Find the three sides, add them up. Are you leaving? Thanks for coming. Oh. Thought you were done. Very common mistake once we start working with triangles is people, I mean, we all agree that the angles add up to 180. We haven't proved it yet. We will eventually. But a common mistake is people add up the three sides and set them equal to 180 also. But we don't know that. We know the angles add up to 180, the sides do not. What's the relationship that we're looking for in this triangle that we use, Max?
The two congruent sides,
Yeah, the two congruent sides. So what'd you do with those two things?
set them equal to each other.
And solved? And what'd you find for x?
I haven't gotten that far yet.
Anybody else? What's x?
Find X.
It's right here.
Oh.
Go ahead. 6?
Yeah.
Okay, good, thank you. Now what, Max?
Now put 6 into each side. Solve for each side and then add the 6 sides together.
So what's a perimeter? Somebody confirm?
Yeah.
Yep, 13, 13, and 5.
Wait.
Waiting. Yes, sir.
Never mind.
Glad I could help. We're good?
Yeah.
Okay. Any problems? Anybody set the 3 sides equal to 180? Add them up and set them equal to 180?
And I fixed it.
Yeah, then you fix it. Yeah, that's why I mentioned it. It happens. Okay. Angles add up to 180, not sides. Figure out what kind of triangle JKM is. It's hard. I use some bad color choices here, but M is right here, in case you can't see it. There's M. Yes, sir.
Is the line that separates JKM and KML, is that right in the middle?
Say that again.
Is the, so the length is 1.5 at the base?
Yeah.
The line that separates JKM and KML, is that right down the middle? So you can divide 1.5 by 2.
Read the first sentence of the question. So what's the answer to your question? Yeah, because M is a midpoint. So therefore, how long is JM?
0.75.
How long is KM? Anybody?
0.75,
Why?
because it's congruent to the side on the other side of the midpoint, which is 0.75.
How do you know that?
Because it just realized this one.
I've got the tick marks on there. So therefore, what kind of triangle is JKM?
Equilateral.
It's equilateral, right. 0.75, 0.75, 0.75. What kind of triangle is KML? Isosceles, good. What kind of triangle is JKL? Any idea?
Scalene because all of the sides have different numbers.
Good, yeah. 1.5, 1.3, and 0.75. So we have all 3 types of triangles represented in that one problem. Okay. Last one. Based on what we talked about with the right triangle already, this should be pretty easy. Notice those are angle measures now, not side lengths. Rules change. And make sure you answer the question. I'd like to know how big angles C and T are, not just how big is X. Strawberry or grape? What? Really?
I don't like strawberry jam.
It's not fair, Jack.
Do you like them?
Strawberry, grape. All right, let's take a quick survey. You have to vote. Uncrustables, grape or strawberry? Uncrustable grape, raise your hand.
Oh, yeah. It's more enjoy sandwich.
Mary! Oh my
Get out.
God!
Out. I don't like peanut
You don't know what an Uncrustable is? Get out that Uncrustable, show her.
I said.
This is gonna be life altering for you.
They're so good.
They're-
They're the best.
Right, and you don't want them to be that good.
Oh,
It's a peanut butter and jelly that's had the crust already taken off and sealed into a little pocket of heaven.
If you think Uncrustables are gross.
Alright, so sorry, let's vote again. Grape?
No.
Oh wait, I'm gonna go.
No.
Yeah.
Okay, strawberry, did I come, no, I didn't count myself. Strawberry,
Nick, what are you doing?
Ew, Max, you can't even have Uncrustables.
why?
I'm allergic to dairy.
Oh,
And I don't
well,
like
dairy, what's,
No,
butter.
and peanuts.
oh, okay, that would be, yeah.
You can only have the bread.
Yeah, so that would be, that's a double whammy, that's the peanut and the butter.
Yeah.
Yeah,
Butter?
I'd probably die. if
Peanut
I
butter.
were to-
Oh.
there isn't really butter in peanut butter, you know that, right?
Depends on how you make it.
Well, if you make it like everybody else in the universe, it's just oil and peanuts and grind the snot out of it.
What's
Butter and peanut butter.
I don't think there's something,
There's
I mean, I'm sure somebody puts, okay, go ahead, you read about it. There's what?
There's dairy and peanut butter.
There is?
Yeah.
Yeah, there's dairy and peanut butter.
Okay.
He's gonna study his Uncrustables.
There's
Hey, how big's X?
1.7.
What is it? 7.3? Can somebody confirm that, please? How'd you get that, Jack? With math.
I added 3x plus 7 to 7x.
Whoops, 3x, okay, we're gonna do that again.
There's
You added 3x plus 7 to,
7x plus 10 and make that equal to 90.
huh? Okay. Did anybody do 3x plus 7 plus 7x plus 10 plus 90 equals 180? Still works. Okay. Magic happens, x equals 7.3. Exactly 7.3, Jack, or is that an approximation?
Yeah.
Exactly, beautiful. So what's the answer to the question then? How big is angle C?
I didn't finish. Wait, I can do it.
I know you can, that's why I asked you.
You got this.
Yep.
28.9?
Is he right?
Yeah.
Yes.
And therefore, how big's angle T, Jack?
I don't know.
Don't you have a calculator sitting in front of you?
61. No. Okay.
Oh, looks like a calculator. What's T? I think 61.1 degrees. Okay. Good. Alrighty then. Are we good? Any questions? Lovely. So now, we can start using the calculator.
Ooh.
Because you should have a distance formula on your calculator, because I think I gave you that one. And we'd like to classify this triangle by sides. And then determine whether or not it's a right triangle. So I'm not even going to bother graphing it. I'm just going to have you guys do some calculations. So I would like to know how long is AB, how long is BC, and how long is AC. So go ahead, start punching numbers in there. Question? I'll give it to you. I'll give it to you before you leave today. Depending on what kind of calculator do you have. Yeah, no problem. Sneeze or cough?
Sneeze. Maybe we're confusing sneeze and cough.
A snuff?
Yeah.
Those are the worst. I feel like your head's gonna explode. Caitlin, you got any of them?
A, B, I got 2.24.
Somebody confirm?
Yeah.
Beautiful. Is that the only one you got?
Yeah.
All right, keep going.
BC, I got 6.71.
Yes?
Yeah.
Okay, we like it. Max?
For AC, I got. That's incorrect. Hold on.
I'm sorry, what was that? You trailed off there at the end. Is it, I got it? What is it? 7.7. 7.07. Alright. What kind of triangle is it, Ella?
This is a,
Is it a right triangle? How do you know?
but it doesn't have a 90 degree angle.
How do you know? How can we check to see if this is a right triangle? You could graph it, but that might not tell you. It would graph, if it graphs nicely and it graphs like that on a coordinate plane, then you'd be good to go. This one's not gonna do that. Daniel,
Pythagorean theorem.
beautiful Pythagorean theorem. If that is a right triangle, Daniel, which one's the hypotenuse?
AC.
Beautiful. So if it's a right triangle, then 2.24 squared plus 6.71 squared would equal 7.07 squared. Check that, please. I'm going to put a question mark above that because we don't know that yet. Yay or nay? No?
No.
Doesn't work. Okay, so which one's bigger? Is this side bigger than this side? Or is this side bigger than that side? In other words, is it this or is it that? Which one's bigger, the left or the right?
Left.
The left. So we all agree that it's this guy.
Y'all.
Could we use that information to figure out what kind of because now that we know it's not right, can we use that information to figure out if it's acute or obtuse?
Possibly.
Possibly is a good answer. It's a safe answer too. Something to think about for tonight. We'll discuss this more tomorrow, whether or not, knowing that we know that a squared plus b squared equals c squared is a right triangle, but what happens if a squared plus b squared is greater than c squared, or a squared plus b squared is less than c squared? Can that help us determine obtuse or acute? Acute. Yes, sir.
Isn't it yay though, because,
Uh-oh.
if you use the radical, like, numbers for those distances, it's equal.
Really? Well, I assume the period's gonna end soon because everybody's packing up. So let's, we'll come back to this tomorrow. And so you're saying that there were some exact radical answers here, right?
Yes.
Radical, square root of something, all right, so we'll pick up with this first thing tomorrow and see maybe it is right and we don't need that. But we're probably still gonna need this for other problems where it's not right. Beautiful. Okay, I'll unlock day one for you. And then tomorrow we'll talk about the day. We'll start by talking about the right triangle stuff, and then go over some homework, and then maybe some more coding. I can't read that on my glasses. Huh? Hold on. I can get my glasses.